Okay, it's problem number 1 out of section 2.8, page 271, number 9 through 18. Problem number 2, page 271, number 19 through 26. These are just adding, subtracting, multiplying, substituting values in expressions. Number 3, you are multiplying two equations, dividing two equations, and subtracting two equations with substitution values. Section 2.8, page 270, example 12. Okay, you also have a graph on number 3 that you have to read values from. Okay, and you're going to have 3 answers on problem number 3. Okay, number 4, on it, you are given an f of x, a g of x, and you have to find a g compose f with a substitution value. It's important to note the order of the compose. The little circle means compose, not times. Okay, page 271, problems 47 through 60. Problem number 5. I give you 2 equations, an f of x, a g of x, and you have to find f compose g with a substitution value. Okay, your citation is section 2.8, page 272, number 47 through 60. I kind of messed up. I didn't have you do any of those purely with the variables. All of them I gave you on compose were with substitution values. That was a mistake in my test making. Okay, problem number 6. Find a minimum and maximum. That means find the vertex and tell whether it's the top or the bottom, basically. Okay. Basically, you will have to give the vertex and identify that vertex as a maximum or minimum. Page 296, number 7 through 14. Problem number 7, you have to identify the graph. I give you an equation that's in vertex form. And then you have to find out by the transformations which graph is the correct one. So section 3.1, page 295, problems 7 through 14. Problem number 8, you've got to find the line of symmetry and the vertex. Okay, 2 answers on this one. And I give you a quadratic. Section 3.1, page 295, number 7 through 32. You may want to use a calculator on this one. Problem number 9, identify the vertex and sketch the graph. This one is multiple choice. You're going to have to find the vertex first, then by first finding the line of symmetry and then substituting the x value into the equation to get the y value, and then determine which one is the proper graph. 3.1, page 289, example 3. Problem 10, determine the end behavior of the graph of the function. Okay. In other words, I give you a polynomial of some degree, either even or odd, and based on that and the sign of the leading coefficient, you have to tell me whether it's up and up, down and down, like this, however it happens. And that's page 302, the leading term test, and then page 311, number 13 through 20. Problem 11, I give you a picture of a graph with a figure on it. And you have to say, is it a polynomial? And then assume the end behaviors I show you and all turning points are in the graph that I give you. And what you have to do is you have to determine the degree of the graph. You have to determine the leading coefficients. You have to find the zeros with their multiplicities. Okay? So you're going to have to do 3 things on this. Okay, problem, and the citation is 3.2, page 312, 45 through 52. Number 12, I give you equation to do long division. 3.3, page 316, example 1, page 325, number 7 through 22. Number 13 is synthetic division. And you have to show your work on these division problems. 3.3, page 325, number 23 through 38. Number 14, you have to use the remainder theorem to determine if the number I give you is a 0 or not. Okay, page 326, numbers 39 through 54. In other words, you're looking to see if you got a 0 remainder or not. Number 15, basically the same thing, except the question asked is it a factor instead of asking, is it a 0? Page 326, number 55 through 60. Number 16, I give you information about it. I tell you its degree. I tell you its zeros. And I tell you that A is 1, the leading term. And then you have to multiply it all out and give the equation, just like we did a few minutes ago. Section 3.3, page 327, number 71 through 82. Problem 17, I give you an equation and you have to list all of the possible rational zeros. In other words, like the 1s, 2s, 3s, the 1/2s, the 1/4, whatever, like we did before. Section 3.4, page 330, example 1, and page 341, excuse me, page 341, number 7 through 12. Number 18, you have to find the polynomial of lowest degree with certain zeros and multiplicities. And I tell you that f of 0 is 36. Okay, so in other words, this is one kind of like we had a few minutes ago where I tell you what the y-intercept has got to be. So that example we did a little bit earlier is a good example on this one. Okay, section 3.4, page 342, 39 through 48. Number 19, similar equation, similar problem, okay? And except this time I've given you some complex irrational roots, okay? So you've got to use that x minus the a plus bi, x minus the a minus bi thing. Page 342, number 39 through 48. Number 20, we're almost through. There are 25 questions. Solve the inequality just like we were doing a few minutes ago. Okay. Page 379, number 21 through 53. Problem 21. I give you a graph and I give you conditions. okay? And you have to tell me what is the domain or the solution set. And this is an inequality problem. Page 378, number 5 through 14. Number 22, I give you an equation or an inequality, and you've got to determine based on that what the domain or the set of possible x's in interval notation, and you also have to make a graph of it. Okay. Page 378, number 5 through 14 also. Number 23, it's a variation problem. And I give you a statement and you just simply have to write the formula, you know, like our y equal kx or y equal k xz or whatever it might, like we talked about previously. Page 388, number 11 through 20. Number 24, it's another variation problem where you have both direct and inverse variation. You've got to write the equation of variation. You've got to solve for k and then rewrite the equation with the k in it. Page 388, 21 through 28. Number 25 is the only word problem in the test, and it's a variation problem. Okay, you've got to write a variation. You've got to do your substitution, find the k, substitute in with the k and the new values, and don't forget to label your answer. It's page 389, number 29 through 42. And that's what's going to be on the test. So we'll see some of you tomorrow, and the rest of you we will see, I will see you online. All right, any questions before we stop? Sorry for going just a few minutes long. Okay, if not, have a good evening.